Okay, today we want to look at Dalton's law of partial pressure. The law states that the total pressure exerted by a mixture of gas is equal to sum of the partial pressures exerted by the individual gases that make up the mixture, provided that these individual gases don't combine chemically. So this is a law on mixture of gases, not chemical mixtures. So mathematically, PTotal is equal to PA plus PP, where PTotal is equal to total pressure exerted by the mixture. PA means partial pressure of gas A, and PB is partial pressure of gas B. Now, in this law, we need to know the meaning of partial pressure. From the word partial, it means the contributing pressures by all the individual gases. So, for gases A and B with number of moles, A and B, we can now derive the partial pressure. Partial pressure or contributing pressure means a mole fraction of each of the gases multiplied by the total pressure. So mathematically, partial pressure of A, PA, is equal to mole fraction of A times PTotal. Mole fraction of A is the number of mole of A divided by the total numbers of mole. So when we multiply it by total pressure, look at what we have. So this is the partial pressure of gas A, mole fraction times total pressure of the gases. Also, we can also say that PB, partial pressure of B, is the mole fraction of B times total pressure, which is number of moles of B over total numbers of mole times the total pressure. So these are the partial pressures. So the law mathematically can be restated as PTotal equals A over A plus B, PTotal, plus B divided by A plus B times B total. This is the same thing as this. But in most of the chemistry textbooks, O-level chemistry textbooks, this is what they see. But in actual sense, PA and PB are this. Depending on the number of individual gases, we are using two gases, A and B. And that is why the mole fraction looks like this. Number of moles of A over total numbers of mole times PTotal, plus number of moles of B over total numbers of mole times PTotal. So this is what Dalton's law is trying to state. Now, let's try to solve one question on this. Let's try to solve one question. Exercise 1. Now, it says the total pressure exerted by nitrogen gas and oxygen gas is 12 millimeters mercury. if there are 2 moles of nitrogen gas and 1 mole of oxygen gas, calculate the partial pressure. The partial pressures of nitrogen and oxygen. So let's look at this question. It says the total pressure exerted by the 2 gases, nitrogen and oxygen, is 12 millimeters mercury. If there are 2 moles of N2 and 1 mole of O2, calculate the partial pressure of N2. So we have that P total from the question is 12 millimeters of mercury. Now, Pn2, that is a partial pressure for nitrogen, will now be a mole fraction times total pressure. And the mole fraction here is 2 for nitrogen over 2 plus 1 for the mixture of gases times the total pressure, which is 12 millimeters mercury. And we have 2 over 3 times 12. 3 can divide 12. What do we have there? If 3 divides 12, we have 4. So 2 times 4 is 8 millimeters of mercury. So the partial pressure exerted by nitrogen in that mixture is 8 millimeters of mercury. Now PO2, that is the partial pressure exerted by oxygen. We now do that of oxygen. The mole fraction of oxygen is 1 for oxygen over 2 plus 1 times 12. And what we have is 1 over 3. 12. So here 3 can divide 12 also, and we have 1 times 4, which is 4 millimeters mercury. Now, to see if the question is correct, if the answers are correct, you are going to add these partial pressures to know if you can easily get the total pressure exerted by the gaseous mixtures. So when we add 8 millimeters of mercury to 4 millimeters of mercury for oxygen, we will easily get 12 millimeters of mercury, which is the total pressure exerted by the mixture. So the answers are correct. So we'll move to the next question in the next video. Thank you very much.